talking about linear relations and functions. And so up here on the board, we have the definition of a linear relation. A linear relation is a relation that has a straight line graph. And so when you think about that, when you hear linear, the root word in linear is line. So when you hear linear, you should automatically think line. That's a line. So it's a relation that has a straight line graph. Now we're going to do lots of work with linear relations this year. Lots and lots and lots of work. We're going to be graphing them. We're going to be graphing them on the netbooks. And so we're going to be examining linear relations a lot. Now basically what a linear relation does is it contains addition, subtraction, or multiplication. Now if I were you taking notes, this is what I would do. Instead of doing contains addition, you could put this. And then what that does is then that limits the amount of stuff you have to do. So that's kind of a good note-taking strategy. You could do that if you wanted. The variables have exponents of 1 only. So you can't have an x squared. You can't have a y squared. You can't have an x to the negative 1. And they may not be multiplied together or be in a denominator. So when it says may not be multiplied together, that means you can't have like an xy. Okay, notice those variables each have exponents of 1, but you can't multiply them together and still get a linear relation. And they can't be in the denominator. That would be like 1 over x. And so an example of a linear relation, x plus y equals 5. That's an example. So now you've got your expressions handy. What's going to end up happening now is I'm going to be having some relations pop on the board, and you're going to have to decide, is this a linear relation or not? Okay, so got your expressions, and we're going to go ahead and look at the very first one. Okay, so here we go. Is this a linear relation? True or false? So there you go. Yeah, I did. I usually don't do it when I put the recording on, so I put it over there so that won't be on the YouTube video. All right, so is that a linear relation? The answer is actually yes, this is a linear relation. Why is it a linear relation? The variables each have an exponent of 1. They contain only addition, subtraction, and multiplication. And so that is in fact a linear relation. So let's look at this one. Is that a linear relation? Yes or no? True or false? No. Reason this is not a linear relation is why? Because of the square root, the thingy. That's right, okay? The square root, that power, just for your information, if you don't remember, that's actually the 1/2 power. So whenever you see a square root, it's the 1/2 power. So that is not a linear relation. Okay, let's look at this one. Is this a linear relation? So go through the check. Do all the variables have exponents of 1? Does it only contain addition, subtraction, multiplication? And this one actually is. Why did some of you put no? Was it because of the 3? Okay, this is actually just a number. So what you do is you view this as -2/3. That's a number, and we're taking it times x.
So was it?
That one is. That one was. Yep. Okay, what about this one? Is this a linear relation, yes or no? Answer is no. Reason being, if you remember on the very first page, I said that variables can't be multiplied together. So this is why it is not a function. You can't have x times y. All right, so basically this is the easy way. You should have an x and you should have a y. Okay, they can have numbers in front of them. All right. And so let's go ahead and keep looking. Is this a linear relation here? Linear relation. The answer is no, because you cannot have 1 divided by x. This is why you can't have a linear relation. Can't be in the denominator. Okay? So let's go ahead and move on. We're going to talk about linear functions today. A linear function is a function with ordered pairs that satisfy a linear equation. It's a function with ordered pairs that satisfy a linear equation. The biggest thing you need to get from this page, right here, this is what a linear function looks like. F of x equals mx plus b. So now as you're writing that down, I want you to think about where you have heard mx plus b. I don't say it right now, some of you already know. Where does f of x equal mx plus b? Where have you heard that before? Yeah, go ahead.
Slope intercept.
This is actually slope-intercept form. Remember we learned about slope a while ago, and we learned that this is the slope. Okay? And we learned that this, and we aren't learning about this right now, but this is just kind of one of those little trivia things to keep in mind because we will come back to this. But this is actually slope-intercept form. And we, as I said, we will come back to this and we'll learn more about slope-intercept form later on. Okay, so now, is this a linear function? So basically, similar to linear relation, just different terms. So is that a linear function? Yes or no? Linear function is written in the form f of x equals mx plus b. And the answer is true. Okay? Reason being, this is actually in the form mx plus b. Here's your mx, negative 3/4 x, and here's your plus 8 plus b. So that's actually a linear function. Okay, what about this? Is that a linear function, yes or no? And the answer is no, good. Okay, why is it not a linear function? Because x is in the denominator, very good. Okay, so is this a linear function? No, why not? Because, yep, this one's the one that kind of messes it up. Okay, you can't have 3xy. You could have 3x minus 4, but not 3xy minus 4. All right, is this a linear function? Oh, just a sec. Let's try that again. Sorry, that was my goof up. There we go. Is that a linear function? And the answer is yes. Reason being, here is your m value, so you have m times x plus b. You can have fractions there, just as long as a variable isn't in the bottom. Okay, so now standard form of the equation of a line. This is pretty important. This is going to follow you all the way through the NISA test. So standard form of the equation of a line. Ax plus by equals c. Now notice here, there's one pretty important statement. A, b, and c are integers. A, b, and c are integers. So ax plus by equals c. A, b, and c are integers. So let's revisit what integers are because we learned about that last chapter. Integers. Do we remember what integers are?
Negative and counting.
The negatives and the counting number. So basically when I think of integers, I think of like -2, -1, 0, 1, 2, 3. So basically it's the positive and negative counting numbers as well as 0. So that's what integers are, remember? Integers are the whole numbers. No fractions, no decimals. no fractions, no decimals. So now we're going to go ahead and look at the following. It says write each equation in standard form. Identify A, B, and C.
So we have to like switch it around?
Yep, that's exactly right. All you have to do is switch it around. So we're going to manipulate this because we know that what needs to be on one side?
X.
The x's and the y's need to be on one side. The number needs to be on the other side. So all we have to do is manipulate this around. So what I could do is I could move, do you agree I could move the 4x over? So if I move the 4x over here, what do I get on the left side?
Negative 4x plus 2y.
Negative 4x plus 2y, and that equals 5. Now first of all, ax plus by equals c, okay, that fits. A, b, and c are all integers. All right, well what is a? A equals negative 4. What is b? 2. What is c? 5. Are they all integers? Yep, so we're good to go. That's all you have to do on that problem. This is first answer right here. This is your second part of your answer. So these answers have two parts. You have your equation, and then you have what A, B, and C are. Okay, we've got another one.
Nope.
Negative 3/10 x equals 8y minus 15. So now this one we're going to have to do something a little bit different first. We can't just jump right to the answer. And why is that? It's because of the fraction. It's not an integer. And so what I'm going to do is I have to somehow get rid of this 10. Ideas?
Times by 10.
Times by 10, very good. So I'm going to multiply this by 10, I'm going to multiply this by 10, and I'm going to multiply that by 10. So you're going to multiply all three. Yes. So first of all, those are gone. What does that leave me with? Negative 3x, good. 8y times 10. 80y. 15 times 10. 150. Good. So, all I did there, get rid of the fractions. This is just like the problem before. So what are you going to do?
Minus 80.
Yep, subtract 80y from both sides. Because what I'm going to do now with that 80y is move it to the left. So I get negative 3x minus 80y equals negative 150. So now I need to identify. What is A? Negative 3. What is B? Negative 80. What is C? Negative 150. Now I got a thought for you, and I just want you to think real quick. What happens if I got this?
Wouldn't it still be the same?
Would that be an acceptable answer?
Yeah, because it's the same numbers and they're still integers.
Okay, this is the thing. Say, for example, I'm up here in this blue step. See where this blue step is? And say, for example, I decided to move the 3x over here to the right. If I did that, I would get 0 equals 3x plus 80y minus 150. Then what would I need to do? I'd have to move the 150 over to the left side. And I've still got the exact same problem. You watched me do this. The difference is that every sign of A, B, and C is the opposite. So whenever you have an instance of where every one is opposite, you're still right. So if you would compare with a neighbor and say, hey, what did you get? If you notice that A, B, and C are all opposite signs, you're still both correct. So that means tomorrow when we check this, you'll have to go ahead and ask and say, hey, I had these, are these fine? Okay. So, last thing we're going to talk about are intercepts, and this is what we're going to graph, and these are fairly easy. Okay, the x-intercept, and this is something that you already should know. It's where a graph crosses the x-axis. The biggest thing you need to take from here, if you want to find the x-intercept, you need to let y equal 0. So it's opposite. To find x-intercept, you let y equal 0. Now y-intercept is where the graph crosses the y-axis. To find the y-intercept, we're going to let x equal 0. So today, this is what we're going to do. We're going to find x-intercepts and y-intercepts. So an x-intercept is where the graph crosses the x-axis, and we're going to let y equal 0 to find that. The y-intercept is where a graph crosses the y-axis, and to find the y-intercept, we're going to let x equal 0. So now we're going to actually look at a problem. It says find the x-intercept and y-intercept for the graph, then graph the equation. So all we're going to do is we're going to find the intercepts, draw a line between them. Okay, 2 points. So first of all, to find the x-intercept. Oh, better lose my pen here. To find my x-intercept, what do I let equal 0? I let what equal 0? Y. So I've got 2x minus 3 times 0 plus 6, and that equals 0. So all I did is I plugged y right up here. So now I have to solve that. What do I know 3 times 0 is?
0.
0. So really I get 2x plus 6 equals 0.
So the negative sign goes away with the 3?
Yep, because anything that's 0 is just gone. So let's subtract 6. So I get 2x to equal negative 3, or negative 6. There we go. What's your answer going to be?
Negative 3.
Negative 3. Remember, we got negative 3 by dividing both sides by 2. So my x-intercept is negative 3. So I'm going to come over here to the graph, and I'm going to put a dot at negative 3. Okay. Now I need to find the y-intercept. So what am I going to let equal 0? X. So 2 times x is really now 2 times 0 minus 3 times y plus 6 equals 0. So now 2 times 0, gone. All right? Negative 3y plus 6.
Minus 6.
Yep, minus 6, so you get negative 3y. Oops, I didn't want to use the same color, but that's okay. And so what does y equal?
2.
2. So that means I go on the y-axis 2, so from the origin, where do I go? Up 2. Now all we have to do is connect those dots. So I'm just going to go ahead and connect those. There you go, and there is your line. So that's all you're doing. You're finding x-intercept, y-intercept, drawing a line. Questions? Very last thing we're going to talk about. You want to make sure that you have enough music for a car trip. Yeah. If each CD is an average of 45 minutes long, the linear function m of x equals 0.75x could be used to find out how many CDs you need to bring. Where do you think the 0.75 comes from?
45 minutes is 3/4 of an hour.
Perfect. 45 minutes is 3/4 of an hour. Okay, so that's where the 0.75 comes from. So, how many hours of music are there on 4 CDs? How can I find that? You know what? I want you to try this one for me. Okay, I'm going to give you about a minute right now. I want you to figure out how many hours of music are there on 4 CDs. And it should just be a number answer. How many hours of music on 4 CDs? Yep, your expression probably turned off. You might have to turn it on. So how many of hours of music?
It's just like really easy.
It's not very hard. Okay, so let's see how many hours of music. Now, since I just asked this question, it's not going to be on there. The correct answer is 3. So, for those of you that got 3, tell me how you got 3.
0.75 times 4.
Right, 0.75 times 4. Because X here is the number of CDs. So now you look at the next one. It says, if the trip you are taking is 6 hours long, how many CDs should you bring? Now this is something that if you look back in the problem, it should be fairly easy to answer because there's actually a clue. Okay, so I want you to go ahead and think. If the trip you are taking is 6 hours long, how many CDs should you bring?
Crap, I don't know what I said. I pressed the number and it didn't end up on the screen, and I pushed send and it just went away. Oops.
That's okay. Okay, so let's go ahead and see what you all answered. And the answer is 8. Very nice job. Good test-taking strategy here. How did you get 8?
Because if you had 3 hours on 4 CDs, then you take 3 times 2 is 6. So you take 4 times 2, and that's 8.
Right. Notice here we got 3 hours, right? And I know that 3 hours was 4 CDs. So 6 hours would be double that, or 8 CDs. Another way you could have done that, okay? If you wanted the one that maybe wasn't as quick, maybe you didn't catch that, and that's fine. What you could have done then is you know that this is your hours. So you could have plugged 6 in here. You've got a basic equation right here to solve that. You're going to divide both sides by 0.75, and you'll get your answer of 8. Okay? So questions? Okay? Here's your assignment then for tomorrow. Pages 72, 73, 16 through 48, the evens.